Hello, welcome student on our channels, the beautiful channel that is the physics point. In these lectures, we are just discuss the characteristics of the electromagnetic waves. In the previous lectures, we are discussed the source of the electromagnetic waves and Maxwell equations. The Maxwell equations is discussed about main purpose behind it. We are revise the Gauss law for the electrostatic as well as magnetism. In these lectures, we are discuss the characteristics of EM wave, electromagnetic waves. Characteristic of electromagnetic waves. We are discuss one by one characteristics. First, we are drawn one of the diagram or graph here. The electric field and magnetic field are perpendicular to each other, and they also perpendicular the directions of propagations of electromagnetic waves. They are right here. The electric field, that is E bar, and magnetic field, that is B bar, are perpendicular to each other. Perpendicular to each others. Then it is also in direction of propagations. In the direction of propagations. This is the first characteristics of the electromagnetic waves. Second characteristic, electromagnetic waves are called transverse waves. Electromagnetic waves, EM waves are transverse waves. Transverse waves or also light waves. Light waves are also transverse waves, and sound waves are longitudinal waves. Just revise for the before we take or discuss some topics. They are also revise and study for the next top contents. They are transverse wave. A cross product of the electric field and magnetic field gives the directions of the electro. This is the for important. Third, cross product. This will be discussed in the vectors. Cross products of electric field and magnetic field gives direction of propagation of electromagnetic waves, of EM waves. We are just discuss the cross product. We are using by the cross product, that is the right hand thumb rules. The cross product of these two different, one is here and another is perpendicular to each other. Cross product of this is the directions of magnetic field and this is the directions of electric field, and cross product of these both will be perpendicular to each, and they gives the directions of waves. The magnetic field and electric field are also perpendicular to each other, then the both are also perpendicular to the propagations of the electromagnetic waves. This is like this. This is not a different. We are just revise some points from the previous lectures, and these are also carry the energy, okay, and cross product are also shows the energy carried, and electromagnetic waves, these are also gives the energy carried by the electromagnetic waves, and the cross product is also gives energy carried by EM waves. Energy carried by EM waves. Number 4. This is also discussed in the previous lectures. The electromagnetic waves electric field and magnetic field are sinusoidally and in the same phase. They are very, this is the electric field and magnetic field, that is E bar and B bar are vary in sinusoidally and in phase This is also discussed in the previous lectures. Characteristic number 5. Electromagnetic waves are produced. How will we produce the electromagnetic waves? The accelerated of the electric charges are produced. The main causes of the formations of the electromagnetic waves are accelerated electric charges, accelerations of the electric charges. They are gives the electromagnetic waves. Electromagnetic waves are produced. EM wave are produced by accelerated electric charge. Accelerated electric charge. Now sixth one. Okay, the traveling speed. Now when the electromagnetic waves are transverse waves are also light waves, then speed of the electromagnetic waves is also equal to the speed of the light waves. Then the speed of the light waves in a free space is equal to the speed of the electromagnetic waves and light waves. Then, but before the discussing it, the medium which can be travel the electromagnetic waves. The electromagnetic waves, EM wave, travels in all mediums. Travels in all medium and also in the travels also in the free space and the speed of electromagnetic waves, that is speed of electromagnetic waves or velocity of EM waves is c. Then c is equal to velocity of electromagnetic waves for a free space is equal to mu 0 epsilon 0. This is equal to 3 into 10 raised to 8 meter per second. 3 lakh meter per second. Okay, 3 lakh kilometer per second or meter per second. This is all about the speed of electromagnetic wave in free space. The EM waves are also travels in a solid medium, is also travels in a liquid medium, then also travels in air medium, and there also travels in free space. When we are given the material medium, and material mediums, that is gives the velocity, material medium for Vm is equal to, this is the velocity in a free space, I will be writing V0. Vm is equal to the susceptibility and permeabilities of their mediums. This is the speed of electromagnetic waves in a material mediums. Next, number 9. Character number 9. The character number 9 is, it can be obey the principle of superpositions. The electromagnetic it can obey obey principle of superposition of superpositions. Principle of superpositions. This is the characteristics number 9. The ratio of the amplitude. How can we calculate the velocities? In the form of magnetic field and electric field. The ratio of the amplitude of electric field and magnetic field at some constant is equal to the velocity of electromagnetic waves. When we don't know about the speed of the light, then how can I calculate the speed of light? Then we know that the amplitude of electric field and magnetic field with some constant, then we are calculate the speed of electromagnetic waves. This is the number 10th. Amplitude is maximum displacement, higher displacement from their mean positions of the vibrating particles. This is the amplitude. Consider this is okay, and the particles here and vibrating the maximum displacement from their original positions or mean position, and this is maximum displacement is called as amplitude, is denoted by A, and these all are amplitude. This is called as amplitude. Then amplitude or ratio, then the ratio of the amplitude of electric and magnetic field, ratio of amplitude of electric and magnetic field with some constant, gives velocity of electromagnetic waves. Then I will be, before the writing of the formula of the ratio of the amplitude, just revise for it, because just revise these 5 characteristics for cleaning of the boards. Then the electric field and magnetic field are perpendicular to each other, and they are also perpendicular to the directions of the propagations. Then it is a transverse wave. It is a transverse wave. EM wave or transverse wave. The cross product of electric field and magnetic field gives the directions of the electromagnetic waves, and the cross product of electric field and magnetic field are also gives the energy of the electromagnetic waves which can be carried out. Then the electric field and magnetic field varies sinusoidally and they are in phase. Electromagnetic waves are produced by the accelerated of the charged particles. This is all about the 5th characteristics. Number of 6th characteristics. Electromagnetic waves are travels in a medium, in all mediums, and they are also travels in a free space. They are travels in a all medium. They are also travels in a free space. Then speed of electromagnetic waves in a free space is gives 3 into 10 raised to 8 meter per second. Then in the material medium, that depends upon the magnetic susceptibility and permeability of that particular mediums. And the electromagnetic waves are also obey the principle of superpositions, and the ratio of amplitude of electric field and magnetic field, these are the amplitude. The ratio of amplitude of electric field and magnetic field gives, and some constant will be gives the velocity of electromagnetic waves. I will be show here. Okay, let's start. The amplitude of electric field, some constant, and amplitude of magnetic field, that is B Q's, then E by B, then this is also is equal to 1 upon under root m mu c. This is also is equal to V. The ratio of amplitude of this gives it. Then the electric field vectors is more prominent than the magnetic field vectors. The electric field vectors is more prominent than the magnetic field vectors. The intensity of the electromagnetic waves, is proportional to the square of amplitude of the particles which can be vibrated. Then this is the most important 11 numbers. Intensity of, or intensity is proportional to, square of amplitude. Then number 12 here, the intensity is proportional to the square of amplitudes. Then the intensity I for the electric field is equal to half of epsilon 0, this is the some constant, into square of the magnitude, and for the magnetic field half of mu 0 into B0 square. This is all about the intensity is a proportional to the square of magnitudes. These are 1/2 is also constant, and permeabilities and susceptibility is also constant. Then next, number 12 and last, the energy equally distributed along in the electric as well as magnetic field. Energy is equally distributed in electric field and magnetic field. Then that is IB is equal to IE. Energy will be equally distributed. This is all about the characteristics of the electromagnetic waves. In the next lectures we are solve a lot of problems. In next lectures we are solve just all problems, and some problems whole lectures will solve problems, and this is the characteristics of electromagnetic waves.